My dear students, welcome to the YouTube channel H2O Chemistry. Subscribe for more videos. You will be interested because the chemistry concepts will be made easier. Today we are going to discuss about percentage composition, or simply called percent composition. You know very well that how will you calculate percentage. So in order to work out, let us assume a student scored 30 marks in his maths exam out of 50. Find out the percentage of marks scored in the maths subject. So the data given are the marks obtained in the maths by the student is 30, the total marks 50. So whenever we need to calculate percentage, we do this calculation. The percentage of marks in maths is equal to mark obtained divided by total marks into 100. So this is very important. Whenever I say percent, so I am converting the given data into 100. So wherever I come across percentage, we have to multiply with 100. Don't forget this. Please remember this. Now, what is the mark obtained by the students? 30 marks. Total mark is 50 into 100. 50, 100. 2 times it is 30 into 2, 60. So the student scored 60% in his maths exam. So it's a very easy way to calculate, right? The same method we are going to adopt it for chemistry. So in this, we are going to calculate the mass percentage composition. It is called mass percentage. Let us see. So to calculate the mass percentage of the elements in the compound, very simple. Let us take a compound methane. The formula is CH4. We have 1 carbon and 4 hydrogen in it. So to calculate the mass percentage of each element, very important. We have a carbon element and hydrogen element. Two different elements we have. In this methane compound, we should know the following. You will see. Look at this. The atomic mass of carbon, the atomic mass of hydrogen, and the method to calculate the molecular mass of compound methane. So these 3 points we have to keep in mind. So in our previous videos, we have learned the atomic mass of carbon is 12. The atomic mass of hydrogen is 1. So to calculate the molecular mass, please verify our videos. So you will be knowing how to calculate the molecular mass as well. I have one more information. If the molecular mass expressed in grams, normally the molecular mass is expressed in unified atomic mass. If the U is changed by grams, then it is called gram molecular mass. Then the gram molecular mass of any molecule is equal to 1 mole of a molecule. It is just a word 1 mole. We know that if I say a pair, what do you mean by pair? Pair is equal to 2 items. If I say dozen equal to 12. Likewise, 1 mole is equal to 6.023 into 10 to the power of 23 entities we call. Let us talk about more in our next video about moles, but you should know what is called this moles. It's an amount of substance. It is a unit to measure amount of substance. Now, so the gram molecular mass of any molecule is equal to 1 mole of a molecule. If that is so, mass of one molecule is equal to gram molecular mass. Am I right? Gram molecular mass. So the gram molecular mass is equal to molar mass, because mass of 1 mole we can write it as molar mass. So this point also we have to clearly know. Got it? So why I need to say this? Sometimes to calculate the percentage, they either use molecular mass or molar mass, but you should be very thorough with this. If the molecular mass expressed in grams, that is nothing but molar mass. Nothing but molar mass. Remember this. We know this detail. The atomic mass of carbon is 12U, the atomic mass of hydrogen is 1U. Calculation of molecular mass of methane. How do you calculate? So we need to know the formula of methane. Now this is the formula of methane. The molecular mass of methane is equal to number of carbon atom into atomic mass of carbon. Definitely is. The mass of this methane molecule come from where? From carbon and the 4 hydrogen present in it. So that's what we are doing. So the number of carbon into atomic mass of carbon plus number of hydrogen into atomic mass of hydrogen. So how many carbon we have? 1 into atomic mass of carbon is 12 plus how many hydrogen I have? 4 into atomic mass of hydrogen is 1. So 1. So 1 into 12 plus 4 into 1 is equal to 16. From this data, what do you have understood? Look at this. In methane, the mass of carbon is 12. Mass of carbon is 12. Similarly, in methane, the mass of hydrogen is 4. Very important. So this is it will be used in the calculation. Alright. So the mass of carbon is equal to 12U. The mass of hydrogen is equal to 4U. The molecular mass is 16. We have calculated. The gram molecular mass or molar mass of methane is 16 grams. Now, the mass percentage of carbon in methane is equal to mass of carbon, because we are going to calculate carbon, right? So mass of carbon divided by molecular mass of methane into 100. So what is the mass of carbon in methane? In methane is 12U. So 12U. Molecular mass we have calculated 16U. So 16U into 100. So U get cancelled. 12 by 16 into 100. So by dividing by 4 table, this is 3 times, this is 4 times. By dividing in 4 table, this is 25 times. 3 into 25, 75%. So the mass percentage of carbon in methane is 75%. 75%. That is an easy way to calculate. We call simple method. In methane, the formula is CH4, right? In methane, how many elements we have? There are 2 elements. We have discussed the percentage means 100%. So if I add all the atom, I'll get 100%. Mass of all these atom, I'll get 100%. So if the mass of carbon is 75, then what will be the mass of hydrogen? You can easily calculate. So mass of hydrogen in methane is equal to, what? Is equal to total percent minus mass percentage of carbon. So we have calculated 100. Total percentage is 100 minus 75 is equal to 25%. So that's what the mass percentage of hydrogen. This is a simple method we can do, right? If it is two elements present in a compound. What else? The straight method. Go to the next one, that is mass percentage of hydrogen in methane. So mass of hydrogen in methane divided by molecular mass of methane into 100, 4 by 16 into 100. So we have calculated mass of hydrogen is equal to 4, just watch here, and the molecular mass is 16, right? So apply here and we will get the answer. Mass of hydrogen in methane is 4, molecular mass is 16, so get cancelled into 100 for the percentage. So the answer will be 25%. So the mass percentage of hydrogen in methane is 25%. If you add carbon percentage and the hydrogen percentage, you will get 100%. I hope you have understood this topic very clearly. Subscribe, my dear students, so that you learn very easily all the concepts in the chemistry. Thank you so much.